So let's look at what a framework is. It's a perspective on sustainability that organizes our understanding. What's a tool? It's a mechanism to use to measure or evaluate sustainable impacts. What's a strategy? A strategy is a design approach to lessen the negative impacts of something. So here are some major frameworks: natural capitalism, the natural step, cradle to cradle, and holistic management. We're going to focus a lot on cradle to cradle. There's also LCA, or life cycle assessment, total beauty, biomimicry, SROI, which is social return on investment, and sustainability helix. We're going to focus mostly on cradle to cradle and biomimicry. Natural capitalism. So again, this comes out of a book and philosophy by Hunter Lovins. And what you can see here is that it's comprised of an additional component. In addition to the financial, human, and natural capital of the triple bottom line, there's the manufactured capital, which is basically incorporating all of those together. So that's the use of materials, manufacture of materials, and then the disposal of those materials. So what natural capital looks at is radical resource productivity, buying time, using resources radically more productively. So what we want to do is be very judicious about the resources that we use. Ecological redesign, making use of biomimicry. So what biomimicry is, if you break it up, bio and mimicry, is something that imitates or mimics nature. And a really simple example of that is taking some of the best of nature and applying those principles in our daily use. I'm sure you're familiar with Velcro. Velcro actually was something that a scientist developed after he was out hunting and noticed that, I think they're called boars, these prickly little, almost like pine cone objects, stuck to his wool jacket. And he tried to replicate it in his lab, and it took a number of tries till he was able to come up with not just the perfect material, but the perfect design and bend of the material, the little hooks that grip. Took quite a number of tries to create, but that was inspired by nature, so that's a great example of biomimicry. Service and flow economies. So that's redesigning all products and processes for sustainability. Investing in natural capital. That's restoring the ecosystem services, so restoring how forests are replenished, whether it's naturally or through a little bit of our own human intervention. And then whole systems thinking. That's really thinking about the entire process and system of everything that we do in an integrated way and a 360-degree view to try and really plan for every aspect and do the best that we can in every aspect. So again, human capital refers to people and society. Natural capital is materials, energy, stability, and diversity. And when we say diversity, we're referring to, it could be the population of animals. So some of them are becoming more and more extinct. So how can we preserve that diversity? You know, if you take away one bug from the Amazon rainforest, it can upset the entire ecosystem there, because each bug or animal has its place in the natural order of things, and it becoming extinct can upset that order and sort of create a ripple effect that has a far-reaching impact, often beyond the locale, so beyond the Amazon rainforest. Losing one bug or animal can have a far-reaching effect. The financial capital, it's simply money, profit, etc. And you may wonder how that fits in, but without money or profits, I'm not talking about ungainly, obscene amounts of profits, but without a company making profits, being able to pay its workers, being able to provide health benefits, those kind of things, it's not sustainable. Sustainable in an enduring sense. And that's really important. Money is important to this system. It's just responsible capital that we're interested in. And manufactured capital, materials, energy, and IP, or intellectual property. So it's basically, what do we create? So here's a look at just a different view on different types of capital. Cradle to Cradle, this is a really important system. This was designed by a gentleman named William McDonough, and this is a really good book if you ever want to do a little bit more in-depth reading, called Cradle to Cradle. So what this looks at is how materials are mined, how they're then processed, turned into products, what happens after the product is no longer being used, and how it then returns to the earth. So it's kind of like an ashes to ashes type concept. So some of the basic concepts here are to eliminate hazardous materials, consider the entire life cycle, which I just described. Materials should be upcyclable, which means that they can then be recycled after the first use into another product, and less bad does not equal good. So a lesser of two evils doesn't mean that it's a good thing, it just means that it's less bad. So what they're saying is to encourage you to strive for better, not just less bad. So here are the major tools, the LCA life cycle assessment, and that's actually something that is part of Cradle to Cradle, doing a life cycle assessment on a product. And companies can actually get certified in Cradle to Cradle. There are different levels of certification. Total Beauty, which we're not going to focus on, the Biomimicry, which I mentioned, and these other two tools. Life cycle assessment. So this looks at the financial impacts, social impacts, and environmental impacts. Here's a great depiction of what the life cycle assessment covers. So if you look to the left, you start with the raw material extraction, moving right into material processing, component manufacturing. So that means if you have a chair, it could have 15 different components, from the seat to the springs that help the chair move, if it's an office chair, the wheels, the side arms, the back piece, the height adjustment piece. Then assembly and packaging. How is it packed? Does it need a lot of cardboard, those styrofoam peanuts? Distribution and purchasing. How far does it travel to a distribution hub and then to a store for purchasing? Installation and use. Service, upgrade, and maintenance. And then disposal and recycling. And you can see off to the right, does it go into rivers, oceans, and waters from any aspect of its life cycle, from raw materials through component manufacturing, through disposal, into landfill, and or to the air, land, and water combined. So that would be all that happens along the life cycle of a product and what a life cycle assessment covers. Financial impacts, social impacts, and environmental impacts. So here's a look at how biomimicry works. It's basically a design process. So by distilling a concept from nature, you can translate it, discover how it works, emulate it or copy it, evaluate it, and test it to turn it into something that we can use, something inspired by nature, like the Velcro. Here are the different components of biomimicry. Self-assembly, that would be something like the Velcro. Solar transformation. So solar transformation can be something like photosynthesis in a leaf. The power of shape. You've probably all seen a spiral seashell. That design has a certain strength component to it that's been borrowed for building and architecture for years and years. Color without pigments. Nature does an amazing job of creating color that we're able to borrow without needing pigment. Cleaning without detergents. Animals like cats have a great cleaning mechanism without detergents. So what properties in nature are able to do this, and how can we create this in products and processes that we men are doing? Water-based chemistry. So there are oil-based products that we typically put onto our finishes, like wood finishing, that can be harmful when they go into the water stream. So if a woodworker puts this oil-based finish onto a table and then pours the leftover finishing product down the drain, it can create a problem in the water supply. Water-based finishes can be easier to break down and less harmful to the water supply, and not need additional chemicals to clean out brushes or clean up after. Metals without mining. How can we create metals without mining and destroying the earth? Green chemistry. So how can we create with both green-based products and also not create chemical reactions that are unfriendly to the environment. Time degradation. That's a concept so that we want something to decompose into the earth, ashes to ashes type concept, but for instance, there is a corn-based silverware and plastic cups and plates called PLA, or I believe it's some kind of a polyacid product. And if that degrades too soon, if it's constructed so it degrades too soon, it's not a good product to eat off, because you imagine you stick your spoon into a soup and the corn-based spoon starts melting. So it needs to degrade over the appropriate time period to be useful in its intended lifetime. Sensing and responding. I think that's just being intuitive to what's needed and being responsive to that in an appropriate fashion. Growing fertility, just making sure that whatever we're doing, what we're taking from the environment, we're actually encouraging to regrow and to have the ability to regrow. So not just encouraging it to regrow, but make sure that the surrounding environment is supportive of regrowth, whether it's a grove of trees or some kind of animal, whether it's lambs that sheep that we take the wool from, just making sure they have the ability to regrow and replenish it, so we're not upsetting the ecosystem. Life creates conditions conducive to life. That's a bit of what I was talking about, again, with growing fertility. And decentralization and distributed control. As we mentioned earlier, that helps people respond appropriately where they live within the conditions that are appropriate to their environment. Simple building blocks. Very simply, can we set up components that build upon each other in a simple fashion? The use of feedback loops. How can we know if something's working? How can we know when a system is in trouble and we need to stop mining from that area, or need to perhaps replenish the soil so it can grow better? So how can we put in these feedback loops to operate more efficiently and in a sustainable way? And what feedback loops can we actually find in nature that tell us these things? Redundancy. Sometimes redundancy is a good thing, but when we have redundancy in the electrical grid can be great when we have an outage. There can be a second system that can support it, but it can also mean if we're using solar power on our rooftop, if we have a redundant system, if we have 3 gray days in a row and our solar system's not generating enough electricity, the redundancy means that we can tap power from another source, so we do have enough electricity. Cyclic solutions and diverse solutions. It just gives us the opportunity to have more solutions, and solutions that give us more options. So here's that seashell design that I was talking about right in the center, and there are a lot of things that we've discovered from these natural models. You may want to go back to this and spend a little bit more time with this presentation. I'm not going to go through all these details right now, but it's pretty fascinating stuff.